don't have to do a lot of chapter 6. We're just going to look at this one section. It's a little dense, so it has some material in there, but at least it's just one section here. So this one's going to talk about a system of two linear equations. And that just means we're going to have two equations that we're combining together. We actually already did this back in exam 1. I didn't call it this, so it wasn't very formal. So we're going to kind of come back and look at what really happens when we have these two lines. So you can see down here below in example 1 where I've got these two equations here. Now we're only going to do lines. So if you have two lines, you basically have three cases. The first case, and I'm just kind of sketching some random lines here, is that your two lines cross at one point. So when they cross like this, we have one solution. That's what we're going to see most often. These cases where we have this one solution. Now, if our lines happen to be the special case where they're parallel, again, I'm just going to draw some random lines here. These parallel lines, they're never going to cross, so they are parallel in this one. So since they never cross, we say they have zero solutions. So these that I'm going to work, we can get no solution for our answer, and we're actually going to see one of those in a little bit. In the third case, this one might be a little bit hard, more difficult to think about, is when they're actually on top of each other. So they're the same line. So I drew with different colors, but this is when they are really the same line. So they're on top of each other. And when this happens, we technically have infinity solutions because they are on top of each other. So they actually cross at every single point. Every point is the answer. So there are going to be infinity solutions for these. For the purposes of our class, since we're going to be looking at like business applications, so solving, like figuring out how much money to charge for different things, we're really going to be focusing on case 1 and case 2. Now, there are two methods to being able to solve these. We actually already used substitution back with our word problems in chapter 3. So I'm going to start with this substitution method. So for substitution, you're going to choose the easiest variable there is to solve for. Maybe there's not an easy one, but if there is one, like right here, I'm going to solve for this y. I'm going to get that y all the way by itself. You could also have negative 2x plus 1 if you wanted. Now what I'm going to do is I'm going to substitute this in to the other equation. So everywhere I see y in the other equation, I'm going to put this long nasty thing. I'm going to keep everything else the same, so negative 3x plus 2. But instead of y, I'm going to substitute in this other stuff. This is why we call it substitution. We're replacing y with these other things. They're kind of nasty, but I can do this. Now, I'm going to solve. And I have to do this because I can only, to get an answer, a number answer, I can only have one variable in the equation. So instead of having x and a y, I had to replace that so I only have x's. All right, so I'm going to solve this by distributing that too. I'm going to combine my like terms. The negative 3 and negative 4 are on the same side, so combining those together would be negative 7x. I'm trying to solve for x, so I'm just going to use all my algebra rules that I already know to get x equals negative 1. Now I'm more than halfway done. All the hard work's done. But I do need to know y as well. You can plug in to find y really multiple places. So you can use either one of the original equations or that equation we solved for. I'm going to use that equation we solved for because that's going to be the easiest. So I'm going to plug in my negative 1, and I'm going to type that in. I'm going to get y is 3. So my answer is going to be the ordered pair negative 1, 3. I found where they cross. I know it's not, I don't have them graphed right, but this is a case 1, and those two lines would cross at the point negative 1, 3. All right, I've got one down here below that I want you guys to try. It's probably going to be easiest to solve for this x, just to kind of let you know. So we'll be solving for the x and plugging it in. So it's not always a y that you have to solve for. I always just go for the easiest one. So go ahead and hit pause and give this one a shot. All right. Coming back from that pause, I'm going to solve this equation. Trying to get x by itself just because that seemed easiest to me. And then everywhere I see x, and I do have to use the other equation, everywhere I see x, I'm going to put in 11 plus 2y. So I'm going to keep the negative 7. Then I'm going to put 11 plus 2y in for x. Then I'm going to keep the negative 2y equals negative 13. And I'm going to solve for y. So negative 77 minus 14y minus 2y equals negative 13. Combining these y's together, they are on the same side of the equation. So I just do exactly what they say. Continuing to try to solve for y. Doing all my algebra steps. Excuse me. I'm going to get y is negative 4. Once I find the y, I'm going to plug in for x. I'm going to use my equation I had before. Remember, you can use any of the original ones or that one. I'll plug negative 4 in, type that in my calculator. I'm going to get x is 3. So the final answer I put down here below is going to be the ordered pair 3, negative 4. It's where these two lines cross.